C# is an object-oriented programming language. This means that you create data objects that contain properties and methods, and these objects are self-contained. Objects are created using classes, which are the set of instructions used to construct an object. So understanding classes is the first step in understanding object-oriented programming. And in this video, I'll explain how to create a class using C#. So the abstract keyword lets you create classes or class members that are incomplete in and of themselves, and they need to be implemented by a derived class. And so what that means is we have a perfectly working program here. I'll go ahead and run it. And we can see that we get the desired result. We've got the class fruit here, and it's all self-contained. And right now, it's just a base class. If I put the abstract keyword in front of it and try to run it again, we're going to get an error message. And the error message is we cannot create an instance of the abstract class or interface. You can see it right there. Now, what that means is that we have created something that's not self-contained. The abstract automatically tells the compiler that this isn't self-contained. I'll go ahead and get rid of that because what I'll do is create a new line here and do this. Abstract class apple. And I'll go ahead and put in our braces. And then I'll go ahead and take these two lines, because what we're going to do is we're going to move them out of there. I've cut them out, and we're going to paste them into our abstract class. Now let's go ahead and make some comments here so we understand what's going on. This is now a base class, and once we put this in, this becomes a derived class. And it's deriving some information from that abstract class apple right here. It's effectively getting kind and cost. So now if I have the abstract, I'll put a little comment in here that abstract cannot be instantiated. And what that means effectively is we can't call it directly. It's not a self-contained item, as it were, and so it needs that derived class here in order to properly execute. Let's go ahead and try this. We'll go and run it. And everything works great. So that works wonderfully. Now, what we want to do here is we want to look at this line where we actually calculate the cost multiplied by 12, so you're buying a dozen apples. What I want to do with this is I want to actually have that being called from the abstract class up here. So I can go ahead and say something like this, abstract, so we're using the abstract keyword again, public string get cost. Now that allows us to call that method from the abstract class, but if I try to run it now, we're going to get an error message. So effectively what's happening is we're calling it, but we need to do something else here in order to make this work. We need to go down to the actual method called getCost and put in override. Like that. Now if I go ahead and debug it or run it, it'll run fine. So you can actually use that override keyword to ensure that you can do things like call methods from an abstract class. And that's really useful in the sense that you can have these little non-self-contained, sort of they're dependent on something else, in this case, dependent on this derived class in order to run. You can use that abstract keyword here and then override to run the appropriate method. Now, let's talk about a sealed class. Sealed classes are different in that they can't be inherited by any class, but they can be instantiated. So if we use sealed classes, we can actually call them. And the whole point of a sealed class is that they can never be used as a base class. And there's a benefit to that in that runtime optimizations can make calling sealed class members a little bit faster. So there is a benefit to using that. They're often used to set up sets of logical instructions that need to be used throughout a program when those instructions don't require any additional modifications. So sealed classes are effectively self-contained. So let's take a look at that. We'll go ahead and here put sealed class fruit. Now that's a sealed class, and let me just put an additional comment in here. Okay, so we can't actually use these for base classes. We can't use sealed for base classes, but we can use them in derived classes. And again, we're making this self-contained little item. So let's go ahead and put sealed down here as well, because what we're going to do here by doing this, we ensure that the method getCost can't be overridden by a derived class. So if I go ahead and run that now, everything works great. So there's really two purposes for these two different things. One, the abstract allows you to set these items up in classes that can't be instantiated, but they give you the ability to access other classes, other derived classes. And then sealed classes can't be used for base classes. They have to be used in derived classes, but they give you the ability to ensure that things don't get overridden. That's really important, because when you start setting up multiple classes in an application, you want to make sure that you set it up so that something in the logic that you've created doesn't get corrupted by something that you didn't anticipate. And that's effectively how you use base class and sealed classes in C#.